Hello friends, in this video I will solve some questions based on limits of trigonometric functions. But first of all I will tell you some important points, and these points will be helpful to solve the problems. So as I have told you earlier also in the previous tutorials that limit x tends to 0 sin x upon x is equal to 1. Now what will be the value of limit x tends to a sin x minus a upon x minus a? Now suppose let us consider that y is equal to x minus a. Y is equal to x minus a. We have assumed this. So as x tends to a, y will tends to 0. Y will tend to 0. So when we substitute these values in this expression, we will have limit y tends to 0 sin y upon y, and it is equal to 1. So this expression is equal to 1. Similarly, limit x tends to a tan x minus a upon x minus a is also equal to 1. So these two results are very useful. Now we will solve questions by using these two results, right? Rest of the questions will be based on these two results. So first of all we will solve a very simple question. Now we have to evaluate limit x tends to pi sin x upon pi minus x. We have to evaluate the value of this expression. Now see, sin pi minus x is also equals to sin x. Now we will substitute this value of sin x here in this expression. So I will get limit x tends to pi sin pi minus x upon pi minus x. So there is one more thing, sin minus x is equal to minus sin x, right? So limit, so sin pi minus x, it can be written as like this, minus sin x minus pi. This is x minus pi, and in denominator we can write pi minus x as like this, minus x minus pi. So this minus will cancel this minus, and we will have limit x tends to pi sin x minus pi upon x minus pi, and it will be equal to 1. Why it is so? Because as I told you before also, limit x tends to a sin x minus a upon x minus a is equal to 1. So here we have used this result to solve this question. Now let us solve another question. Now we have to evaluate limit x tends to pi sin 3x minus 3 sin x upon pi minus x raised to power 3. Right. Now we have to solve this question. So first of all, see what is sin 3x. Sin 3x is equal to 3 sin x minus 4 sin cube x. So here we will use this formula, right? So in this expression we will substitute this value of sine 3x. So we will get say 3 sin x minus 3 sin x, it is 0, so they will cancel each other. Now what I have here, limit minus 4 sine cube x, right? As I told you before also, sine pi minus x is equal to sine x, right? So we can write it like this: sine cube pi minus x upon pi minus x raised to power 3, right? It will be equal to minus 4 into limit x tends to pi. To denominator we can write it like this: x minus pi cube, and in numerator we can write it like this: minus sine cube x minus pi. This minus will cancel this minus, right? It is equal to minus 4 into 1, right? The value of this expression will be 1. Now another question. Limit x tends to pi by 2 cos x upon pi minus 2x. We have to evaluate this. Now what is cos x? We know that sine pi by 2 minus x is equal to cos x. So in this expression we will put this value of cos x. So we get limit x tends to pi by 2 sine pi by 2 minus x, right? Now in denominator we will take 2 common. So when we take 2 common we will have 2 pi by 2 minus x, and it is equal to 1 by 2 limit x tends to pi by 2 sine x minus pi by 2 upon x minus pi by 2, right? So it will be equal to 1 by 2 into 1. This term will be equal to 1. Why it is so? Because here I have used this theorem: limit x tends to a sine x minus a upon x minus a is equal to 1, right? So these two results are very helpful to solve the questions. Now another question which is similar to this one, which we have solved right now. This is, we have to evaluate the limit of this function as x tends to pi by 2. Limit x tends to pi by 2 cos 3x plus 3 cos x upon pi by 2 minus x raised to power 3, right? So first of all, see what is cos 3x. Now we have to solve this question. What is cos 3x? Cos 3x is 4 cos cube x minus 3 cos x. Now we will substitute this value of cos 3x here. So we will get limit x tends to pi by 2, and in place of cos 3x we will write this expression: right? Now this plus 3x and this minus 3x, they will cancel each other because their sum is equal to 0. So now we have 4 limit x tends to pi by 2 cos cube x upon pi by 2 minus x raised to power 3. It is equal to 4 limit x tends to pi by 2. Now what is cos x? It is sine pi by 2 minus x. So in place of cos cube x, what I will write? Sine cube pi by 2 minus x upon pi by 2 minus x raised to power 3. And it will be equal to 4 limit x tends to pi by 2 sine cube x minus pi by 2 upon x minus pi by 2 cube. In previous question I have explained you how it comes here, right? How we have converted sine pi by 2 minus x into sine x minus pi by 2, and in denominator we have converted pi by 2 minus x into x minus pi by 2. So this thing I have solved in previous question, right? Now see, it will be equal to 4 into 1. Now the value of this expression will be 1, right? So our answer is 4 into 1, that is 4. Now next question is, we have to evaluate limit x tends to pi by 2 cot x upon pi by 2 minus x. So what is cot x? It is equal to tan pi by 2 minus x. So here now we have limit x tends to pi by 2 tan pi by 2 minus x upon pi by 2 minus x, right? And it will be equal to 1, right? Because x tends to pi by 2, therefore pi by 2 minus x will tend to 0. And I have told you earlier also, as limit x approaches to 0, tan x upon x is equal to 1, right? So here pi by 2 minus x, it tends to 0. Now another question. Now we have to evaluate limit x tends to pi by 2 minus x into tan x, right? So it is equal to limit x tends to pi by 2. Now pi by 2 minus x. What is tan x? Tan x is 1 upon cot x, right? And what is cot x? It is tan pi by 2 minus x. So this expression will be equal to